So, hello. I want to just welcome you to the webinar Battery Abuse Testing. So, my name is Tim Frittel. I just want to introduce myself a little bit. I'm working since now 10 years for ZwickRoell. I'm responsible for all the special machines. So, based on our standard products, if you have some special requests, then I will be responsible for all kind of static torsion tests and in our case, battery abuse test. Actually, the webinar that I do it together with Matthias Eitner from Weiss Technik. But he has no time today, so there are some foils in the presentation. That is his part. I try to catch up this part from him. Hopefully, for the presentation, I will switch off my camera. Hope you enjoy this webinar, and then if you have questions, then I will come back to you later. So for for this battery abuse testing, actually, as you know, there are different kind of situations where overcharging can happen with batteries. Therefore, it's important that we go ahead and test these batteries in different kind of situations. And therefore, I want to go with you together through our presentation. This means we are starting with the battery testing, standards, mechanical parts. Afterwards, I want to show you different kind of battery testing solutions. Then I will go through the extreme event chamber from Weiss Technik and tell you something about our testing machine, and then give you an overview about different kind of testing scenarios. As you can see, we have different kind of potentials for what can happen with batteries. Actually, if we are working on a normal range to 80 to 100 degrees, nothing happens. But if some failures occurs in the battery, depending on which kind of stress we give to the battery, it starts to decomposing. So by 120 degrees, it can we get to a critical status. There it starts to begin some outgassing or leakage of batteries. If the temperature is getting higher, then it more or less starts to go through a thermal runaway. This means in this combination, a chain reaction will start. This means the temperature rise, and then most of the times, then oxygen happens, and in this kind of combination, it can happen that, depend on the material of the battery composition, it can start the explosion, for example. And there are some tests where we are going directly in this thermal runaway situation. This means, for example, nail penetration, crash tests, or thermal overheating. These are the mechanical parts. Additional, there are some electrical tests. This means that we have short cycling or overcharging of the battery, where we are going directly in this thermal runaway to see what's happening with the battery itself. Therefore, we have a declaration. So most of you maybe know this OICAR hazard level tabular, where you can see that starting from hazard level 0 to 7, where you have with 0, you have no effect, so nothing happens. Then we have more or less, you can see from 2 to 4, there's no fire, no flame happening. This means a leakage of the battery can be occur, but it's not. Of course, it's critical, but not that critical. And after 5 to 7, there it's more or less more critical and even dangerous if you are next to the battery. And therefore, we worked out a solution that I will present you in the next few foils. Most of the testing standards are shown here, or you have an overview about testing standards that we are get from our customer. Most of the well-known standards are the OICA 100. You will see it here on the top. Then the IEC standards, as well as the UN 38.3 standard. In many of the standards overlapping, and individual test parameters are a little bit different, but most of them are similar and has some small changes. Additional, there are coming standards from customer side, where they have their individual testing parameters, where are even more stricter than the normal standards that you see here. What we are realizing is that the standards are placing more and more importance on safety testing facilities as well as environmental protection. So this means some customers just do their tests under open air. This means the outgassing just go directly in the environment and pollutes more or less the air. And this is why we decided to find a safe test solution. For this test solution, I can show you what different kind of testings machines we can offer. So this means if a customer wants to do their own safety concepts and just using our material testing machine, so this means without any hazard level from our side, you can just use our whole product portfolio that we have from ZwickRoell. This means from minimum of 500 Newton up to 2,500 kilonewton. We have electronic mechanical machines which can be used to do tests. But therefore, you or the customer is responsible for the safety concept. If we are just working only with hazard level 3, then we can use our temperature chamber from ZwickRoell. So this is no abuse test. This, for example, if you have swelling tests where you don't go to the limits, then you can use our test environment up to hazard level 3. What I just mentioned before, that there will be maybe some leakage of the battery, but no venting, fire, or flame. If you go one step further, then we realized together with Weiss Technik one solution where it can go up to hazard level 6. This means there will be no explosion. Here in this case, we used inerting the chamber, that if a fire occurs, that we can more or less control the fire. But with this chamber, there should be no daily abuse. So if there is a fire or anything like this, then you have to change some parts of the chamber. So it's not for daily abuse, but you can go more or less a little bit more to the limits than with the hazard level 3 chamber. Our new combination that we did also together with Weiss Technik is our hazard level 7, the extreme event testing machine. This means here you can do frequent events. This means more or less every day you can do tests with this chamber. later I will just go deeper to this product, or more or less we are now talking only about this hazard level 7 product, the extreme event testing machine. I just mentioned before we have different kind of tests. Means well known is the nail penetration, then some crash tests on the battery itself, or some swelling test where you charge and uncharge the battery, or some customer specification tests where they decided to have their own test sequence. Means if you have a swelling test, then combine it with temperature, and maybe later you just put a nail in it or whatever. So there, our testing machine with our testing program is really flexible, where you can do more or less every test sequence which you like to do. Now I just want to come up to our machine that we just built up. This was a 100 kilonewton machine with 6,000 millimeter per minute. We have different concepts with 400 kilonewton, also 5 kilonewton. The importance is that we have here a testing machine, and not only more or less a hydraulic cylinder or pneumatic cylinder that just pulls in the nail. Here with the testing machine, you have precise force and travel measurement. This means especially for the swelling test, you can, if you make this charging and uncharging, you can just hold the position and then measure the force during the charging of the battery. Or you say, okay, we want to hold the same force on the battery pack, and then moving by, if the battery swells, moving the crosshead and measure then the travel of the battery, so the swelling. So there are different kind of sequences that you can do. Then of course with our machines, if you know ZwickRoell, then you can add different kind of modules, measure the electricity. You can do with our machine, you can with the test expert software, you can handle the overcharging by themselves, and just get all the informations in one software. The electronic should stand outside the testing room. Later I will come up, get you some information about the testing room. Of course, we need anyways a safe environment for this machine. And as I already mentioned, we are flexible in force and testing speed. This means we can have here 5 kilonewton up to 6,000 millimeter. This is a combination with 100 kilonewton, also 6,000 millimeter per minute. And here the test area, you can add different kind of testing tools. The area really flexible. For the chamber itself, Weiss Technik has developed this chamber with a patented flap mechanism. This means if we have, depending on the flaps will open at least at 1 bar pressure inside the chamber. As I mentioned, depends on the flap, maybe it's earlier a little bit. The test volume is 1,000 liter. At the moment, they also have a new test chamber, or the volume is now bigger. Now it's also possible to have a volume of 1,500 liter. This chamber is fire protected design, and the explosion, the testing chamber is the first stationary explosion protection that they have. I will go now more or less to the foils that I got from Matthias Eitner, who is responsible from Weiss Technik. As I mentioned, The extreme event chamber is a new innovation in the product portfolio of Weiss Technik. This is the first test chamber with this stationary explosion protection from Weiss, and this chamber is specially designed to withstand frequent explosion, uh, um, so you can do more or less daily explosion. The chamber itself is certified according to the ATEX directive in gas group C based on hydrogen, which represents actually the most critical requirements and confirms the safety and reliability of the new testing chamber for battery application. So, and if we go deeper into the test chamber, as I mentioned, there's a volume of 1,000 to 1,500 liter. This is the new version. Weiss Technik has fireproof seals up to 650 degrees. So this means if there fire occurs, then the environment outside the chamber is extremely safe. Additional, they have here some exhaust air and air supply where you can additionally add some heating or cooling system. Then in the front, now you see there's a glass where you can see through to have a view inside the chamber. And with this additional locking system from Weiss Technik, you are safe that the door is closed and the inside the flap mechanism, which here is on the top, that the flaps can go up during the pressure. For the additional parts that you can add to the extreme event chamber, so you can also just, if you don't have any mechanical test, then of course the extreme event chamber is also available by themselves. There you can add a temperature and cooling unit from Weiss Technik. If you do 24/7 test, of course, at one point it's possible to replace this inner container. This means the inside. Then you have some inlet ports. There are 5 inlet ports. You can see here one here in the back, at the side, here on the top, where you can add some additional measuring systems or whichever you need or whichever you like. A high-speed camera can be installed here on top, which can be combined with our testing expert software, where you can follow up the abuse, the event, what's happening, and then you can see at any time which force or measurement you have, so you can combine it together in one point. Then the filtering unit that comes on top of the machine, because if the flaps are open, then still some air will or some gas will come out, and this has to be filtered. So there's also a filtering system now available. And if you want to have additional inertization, then this is also possible with the chamber of Weiss Technik. As I mentioned before, even during this thermal runaway of the battery, there are coming some harmful substances out, and this is of course then also dangerous for health, and therefore you anyways have to put the extreme event testing machine on in a different room. More or less, we just call it this black and white safety concept. This means we have a black area where the extreme event is inside. Of course, with the extreme event testing machine, you don't. If you have an event with an explosion, then more or less the most of the gas and the parts are, or all the parts are inside the extreme event chamber and not spreading the room fully or spreading the room. Of course, we anyways need this separated area because even when you start opening the door, you just contaminating this room. Therefore, anyways, you need to have a black and white area. Additional, you need to have a filtering system, then safety door to close the door that nobody is inside the room. So there you need to have some fulfilled concept to fulfill the test. So then I want to give you a short overview which kind of tests Weiss Technik has done to evaluate their testing, the extreme event chamber. There's a kg value where this represents the bar per meter seconds, and Weiss Technik did some tests with hydrogen and oxygen, and there they just used the perfect mix ratio where it occurs the explosive mixture that you can get. And they used their chamber. As you can see, there are steel flaps and composite flaps. This is what I meant before, that the flap will open earlier depending on which kind of flaps you use. And there you see that with this hydrogen and oxygen mixture, they occurred 0.65 bar. There the flaps are opened, and with the composite it was a little bit earlier. And the ratio with the battery, it was less the pressure. So the pressure here with this hydrogen oxygen mixture was much higher, and with a battery single 190 ampere hours, the pressure was more or less only 0.2.5. If with the module it was less, because there you have this that one battery goes first and the other, and was also a chain reaction. So you can see with this foil that Weiss Technik did more or less a perfect job to have a safe environment, and that the chamber can withstand a lot of pressure. Then I would stop the webinar. If you have, as I mentioned, if you have later further questions, then just come up to us, and then we will inform you. Then have a nice day, and hope to see you. Bye.